This 6-1 is about rational expressions. And a rational expression is a ratio of polynomials. It basically is the rational numbers as polynomials are to whole numbers. Okay, so here's an example, rational expression, 1 over x, or x squared plus y squared over x squared minus y squared, or x squared minus y squared over x squared plus 2xy plus y squared, and so on. Now, okay, as usual, you can simplify a ratio by canceling common factors. For example, this expression here, x squared minus y squared over x squared plus 2xy plus y squared is what? Well, the numerator is a difference of squares, which turns into a difference times the sum, x minus y times x plus y. Here's 1, 2, 1. So that's a square of a sum, x plus y times x plus y. Now these have a common factor of x plus y, which cancel. So we're left with what's left over, this, x minus y times x plus y. So that's what this section is about, canceling, simplifying such expressions. So, short section. All right, here we have 4 examples. 4a squared minus 25 over 2a minus 50. What is it? Okay, 4a squared minus 25 is a difference of squares. The square of 2a minus the square of 5. 20a minus 50 has a common factor of 10 times 2a minus 5. So this difference of squares is 2a minus 5 times 2a plus 5, all over 10 times 2a minus 5. 2a minus 5's cancel. We're left with what's left over, 2a plus 5 divided by 10. And okay, and by the way, in these problems, I do request that you go as far as possible, canceling as many factors as possible. Anything short of that is, I'll call it incomplete. So you have x squared plus 2x plus 1 over x squared plus 4x plus 3. Now this in the numerator factors into x plus 1 times x plus 1. This in the denominator, after a little bit of search, is x plus 1 times x plus 3. The x plus 1's cancel. We're left with this, x plus 1 over x plus 3. For this one, 2h squared plus 9h minus 5 over 4h squared minus 4h plus 1 is what? Now, okay, I guess from here to here, I really admit that I skipped the AC method steps. I didn't want to bother with that right then. Maybe in later examples, I'll go through all that trouble. But after going through the AC method for this, 2h squared plus 9h minus 5, we're left with 2h minus 1 times h plus 5. This one you could recognize as a square of a difference, 2h minus 1 squared. Either 2h minus 1's cancel, we're left with what's left over, h plus 5 over 2h minus 1. This one is relatively easy. 16p to the third q to the second over 24p q to the eighth. Here we don't have to do any factoring of trinomials, it's just look for expressions. 16 and 24, well, 16 is 8 times 2, and 24 is 8 times 3. So this is the greatest factor in common between 16 and 24. We have p cubed and p to the first, so pull that out, leaving a p squared in the numerator, no p's whatsoever in the denominator. Q to the second over q to the eighth, pull out a q to the second, leaving no q's in the numerator, q to the sixth in the denominator. 8pq squareds cancel, leaving what's here, 2p squared over 3q to the sixth. Okay, I believe that does it. Let's stop recording.